Hello, and good morning, or good afternoon, or good evening. I don't know, or good night. I don't know what time you're watching this. Hey, y'all. So I wanted to do our next set of notes. So last time we chit-chatted a little bit about evaluating inverses and how that was different than solving equations. So just as a reminder, when you evaluate inverses, that means we're not trying to solve for a variable. What we're doing is just trying to figure out what a function like simplifies to, right? We're evaluating something. So there are two main differences. Number one, we're not going to have a solution set around our answers because there's no variable. We're not solving for anything, right? Number two, with trigonometric functions, in order to have an evaluative answer for an inverse, we have to limit our domain. So there are restricted domains for each one of our trigonometric functions. So for sine, cosine, and tangent, those are the ones that we talked about. And those restricted domains are called principal values. So if you have no idea what I'm talking about, stop this and go back to the notes that I put out on the 16th and 17th, I believe, April 16th, 17th. Go click on the assignments for that day, and you should find all of the stuff that you need to know there. Okay, so what I wanted to do today, pardon me, was just to go ahead and walk you through a few more different types of examples of inverses. So let's just go ahead, let's get started. Let's kick it right into high gear. I'm going to go back. I should specify these are some examples. So as usual, guys, I hope that you are writing this stuff down on your own notes, keeping this as similar to school as you can. So here's what we're going to do. We're going to take the inverse cosine of the cosine of negative 5 pi over 3. So you might be thinking to yourself, holy cow, those cosines just cancel out. The inverse and the cosine, what? Get it out of here. So you're not entirely wrong, but I want you to be careful because this is what we talked about last time with the principal values, right? So if I drew a little unit circle for the location of negative 5 pi over 3. So negative 5 pi over 3 means I'm swinging backwards around the unit circle. So instead of going this way, like I usually do around the unit circle, I'm going this way. So negative 5 pi over 3 means I'm going all the way back to there. That would be negative 5 pi over 3. Which makes sense because positive 5 pi over 3 would be down here. So it's just kind of a same thing, opposite direction, right? So the cosine there, what is the cosine right there? Remember, cosine is the x value. So the cosine there at negative 5 pi over 3, how far did we go out on our x-axis? That is 1/2. So I'm looking for the inverse cosine of 1/2. So y'all, basically what I have done is I have taken this bit and I have replaced it with 1/2. So the cosine of negative 5 pi over 3 is 1/2. So now I need to go backwards and say to myself, okay, self, what is the inverse cosine of 1/2? So what this means, I'm looking for the angle that has the cosine 1/2. So what angle has the cosine 1/2? But I also need to remember that I'm paying attention to principal values. So that is only values for cosine, that is only values between 0 and pi. So the top of our unit circle, right? Quadrants 1 and 2. So negative 5 pi over 3 is not, in fact, in the principal values, right? Because negative 5 pi over 3 meant that I had to swing all the way around the circle to get here. That's not going to work. I have to stay within that little shaded area. So that means I'm going to go up here, boop, boop, and that is just pi over 3. And that is going to be my answer. Remember, I don't need a solution set around it. If you want to put like a box around it to signify answer, that's fine. You can do that. That's great. So that would be my answer for that puppy right there. Okay, questions? I don't know why I'm asking for questions. This is a recording. I do this every single time. Let's do another one. If you have a question, y'all, please send me an email. And if I don't answer your email, send me another email. That's fine. Okay, let's do another example. Let's take the sine of the inverse sine of 2. The sine of the inverse sine of 2. Now, what you should say to yourself every time you see this little inverse notation up there, this whole thing, the inverse sine of 2, that represents an angle, right? Specifically an angle where the sine value is equal to 2. Can you tell me what angle has a sine of 2? Let's go ahead and look at the unit circle. Sine, ooh, let's get, okay. The sine is the y value. So at what point do I have a y value of 2? So that's going to be right up here, the tippy top. Wait a second, the sine value right there is 1. Where's the sine value 2? It's never 2, y'all. That's undefined. It doesn't happen. So that means that this answer is, in fact, undefined, right? I should put that in blue so it matches the rest of the, bear with me as I just fix this. Yeah, undefined, right? It doesn't, there is no angle that has a sine value of 2, so I'm not even gonna worry about it. It's toast, I'm out, done so. Okay, y'all, let's mix this up a little bit. Let's get a little crazy. Example. Boop, boop. Let's do this. Let's take the sine of the inverse cosine of 1/2. Ooh, okay. I see what you got there. The sine of the inverse cosine of 1/2. So remember, I see this notation and I think to myself immediately, hey self, that means that this whole thing represents an angle. So I'm looking to take the sine of the angle that has a cosine of 1/2. So what we need to do is we need to figure out what angle has a cosine of 1/2. There's my little unit circle. Okay, cosine is the x value. So I'm going to stick to principal values here. Sticking to principal values because I'm evaluating. I'm not solving, I'm evaluating. So I'm only going to have one answer. So where is the cosine 1/2? That happens right here at pi over 3. So that means I am taking the sine of pi over 3. So as a reminder, what I have just done is I've replaced this with this. Those are the same thing. Pi over 3 is the angle where the cosine is 1/2. So now I'm taking the sine of that angle. What's the sine of pi over 3? So we're still at that spot right there. The sine of pi over 3, my friends, is in fact the square root of 3 over 2. That's it. I'm only going to have one answer. I'm evaluating. That's it. Done. Walk away. Okay, easy, right? Piece of cake, right? We're doing good. Okay, let's do another one kind of like that where we're mixing up trigonometric functions in the same problem. Example. Let's try this one on for size. Let's do the tangent of the inverse sine of -1/2. Okay, so once again, I'm going to keep saying this because I think this is an important point to make. I see that little inverse notation up there, right? So what I'm going to tell myself is self, that means this whole thing represents an angle. This is the angle where the sine is -1/2. So let's draw my little unit circle, boop, boop. Draw my little unit circle over here and figure out where on that unit circle is the sine -1/2. Remember, principal values. I'm keeping to my principal values because I'm evaluating. So sine is the y value, so -1/2 would be right here. My principal values would be -pi over 6. I know you're thinking to yourself, 11 pi over 6, that's the same thing. it is, yes, but for principal values for sine, our principal values are these guys over here, right? Quadrants 1 and 4. I cannot, that means leave those quadrants. I can't go all the way around to get to 11 pi over 6. It doesn't work like that. It's like I'm trapped in the green space. So I can't, I'm just like, hey, I want to get out, but I can't get past here. I can't get past here. So that's fine. Just swing down to negative pi over 6. Booyah. So when you're evaluating principal values, don't forget. Okay, so what that means, y'all, is I'm taking the tangent of negative pi over 6. Now, recall that the tangent is equal to the sine over cosine. So that's going to be the sine of negative pi over 6 over the cosine of negative pi over 6. So let's work that out real quick. The sine of negative pi over 6, we already know, we just said that up there, is negative 1/2. What's the cosine at negative pi over 6? It's the x value. So the cosine is going to be rad 3 over 2. So booyah, that's the tangent, right? I hope you didn't walk away. I hope you didn't put a box around that. Let's simplify that. Holy cow. We've got some fraction on fraction action. So that's going to be negative 1/2 times, I'm going to do a little flippity flop there, times 2 over rad 3. Those 2's are going to cancel out since I'm multiplying and there's no addition in sight, so they'll cancel out. So that leaves me with negative 1 over rad 3. I don't want to leave any radicals in the denominator, so I'm going to multiply both top and bottom by rad 3, which means I end up with negative rad 3. Oops, not over rad 3, over 3. And that, my friends, is in fact the answer. Let's make it a little 3D box. Yeah. Sweet. Yay. I realize this took a lot of vertical space. I do like it when you work vertical, so I can like follow your work straight down. If you want to work in columns, so you're not leaving all this white space, that's totes fine. If you want to work on one page, that's totes fine. Do whatever you want to do. I'm flexible. Okay, guys, I want to do one more like this, and then we're going to move to something very slightly different. What I would love for you to do, I'm going to write this example. I would love for you, after I write this, to pause this, try this on your own, and then come back and check. So I want us to find the cosecant of the inverse cosine of negative rad 3 over 2. Okay, so pause, try this on your own, and then come back and check it. Pause. Did you pause? Hopefully you did. Okay, I'm going to work this out. Okay, so I see the inverse notation, which tells me, I'm going to go ahead and make a note of this. This is an angle, so I know I need to find the angle where the cosine is negative rad 3 over 2. I'm thinking of principal value, so for cosine, that is quadrants 1 and 2. Cosine is the x value, so that means I'm going backwards this way. So that means my cosine is, oh, let's draw that a little better. Oh golly, I deleted a lot of things. I didn't mean to do that. My cosine is going to be right about there, which is 5 pi over 6. So far, so good. So what I am finding here is the cosecant of 5 pi over 6. So just as a point of order, I replaced all of this. The angle that works with is this right here. Okay, now what I'm going to do is the cosecant is 1 over sine, so this is actually equal to 1 over the sine of 5 pi over 6. Y'all, what is the sine at 5 pi over 6? That's the y value, so that's going to be 1 over 1/2. Little fraction on fraction action, little that is just going to be equal to 2, right? 1 divided by 1/2, how many halves are there in 1? There's 2. Shablam, donezo. Okay, so that is some composite examples that you can find on the unit circle. So what happens if you can't find it on the unit circle, and I am still asking you to find things in exact form, which means not using your calculator and getting a bunch of decimals, right? I want you to find things in exact form, but you don't have your calculator to help you out. So let's do an example. like that. And this is actually going to be much, much, much easier than you think it is, because you're probably thinking to yourself, I can't do it without my unit circle. But lo, you can. So I'm going to say without your unit circle. Okay, so let's try this one on for size. We're going to find the tangent of the inverse cosine of 3/5. Okay, now you're going to see that hopefully and recognize that since I have the inverse notation right there, that this whole thing represents an angle that has a cosine of 3/5. So what angle has a cosine of 3/5? That does not exist on the unit circle. And I don't want you to go grab your calculator and type in inverse cosine because it's going to give you a long number and I don't want you to do that. I want you to be able, even though you can do that, I want you to be able to show me your work and how you figure this out. So check this out. What you're going to do, y'all, you're just going to draw a triangle. So if I know that the cosine is 3/5, I know that the cosine is SOHCAHTOA. Cosine is, let me actually make this pen. This is the adjacent over the hypotenuse, correct? So since it is positive, and I'm thinking primary values here, this is going to be in the first quadrant. And what I'm going to do, I'm not going to give you anything that's not in the first quadrant. So hopefully that should set you at ease. Everything I'll give you regarding drawing triangles and stuff on a test will be in the first quadrant. Okay. So if I draw a triangle, so here is my angle theta. I don't know what that angle is. I don't actually need to know what that angle is, but I know that the cosine of that angle is 3/5. So I know that the adjacent side to this angle right here is 3, and I know that the hypotenuse is 5, right? So here's my theta. The cosine is adjacent over hypotenuse, so 3/5. Y'all, the tangent of this fancy angle, what is tangent equal to? Anybody? Anybody? Tangent, if you think about SOHCAHTOA, anybody know? I am just going to assume that somebody is saying, hey, the tangent of theta is equal to the opposite over the adjacent. Here's the problem. If this is my theta right here, and it is, I don't have the opposite side right here. So I need to go find that. How can I find that? Y'all, it's our good friend, the Pythagorean theorem. You might already know this because of Pythagorean triples. That's also fine. But if you don't know your Pythagorean triples, let's just use Pythagorean theorem. Keep it OG, as the kids say. Y'all don't say that anymore? I don't know. I'm a few years behind. It's fine. Okay, so I'm going to make that 3 squared. I'm going to make this, let's just call this x. So I'm going to make that x squared equals 5 squared. So that is 9 plus x squared equals 25, which means x squared equals 16, which means x equals 4. And here's the thing. I know technically when I take the square root, when I'm solving, I want to take positive and negative, right? I know this is a positive 4 because I'm in quadrant 1, right? So I know that I'm going to be going up 4 rather than down 4 because quadrant 1. So that means that x equals 4, which means my tangent, the tangent of theta, opposite over adjacent, is going to be 4/3. And that's it. I don't even need to find the angle. I don't need to go backwards and find the angle. I just need to find that tangent right there. That's it. Piece of cake. Okay, I'm going to do one more like that, and then I'm going to stop talking and be done with these notes. So you can go enjoy the sunshine. Or is it raining today? I don't know what day it is. It was sunshiny today. It was lovely. Okay, let's do this last one. We are going to take the sine of the inverse tangent of 5. Okay, we're going to take the sine of the inverse tangent of 5. So once again, there's the inverse, which means this whole thing, the inverse tangent of 5, that is the angle where the tangent is equal to 5. So I'm taking the sine of an angle. Okay, so I know the tangent, let's think again about SOHCAHTOA, SOHCAHTOA. I know that the tangent of an angle is equal to the opposite of the adjacent. I also know that 5 is not on the unit circle. So we're going to draw a triangle. Wait, opposite over adjacent, but that's only one number, Mrs. Ray. What do you mean? How can that be opposite over adjacent? It just looks like opposite. Y'all, let's just turn that puppy into a fraction. So it's going to be 5 over 1. So let's get in here. That's going to be my opposite. That's going to be my adjacent. So let's draw that triangle. Remember, everything's going to be in quadrant 1. So the adjacent side is going to be 1. The opposite side is going to be 5. There. Oh, let's draw it like it's actually on a circle. I guess I don't have to. Y'all, the unit circle is irrelevant here. I don't have to draw the unit circle. I don't know why I'm insisting on doing that. So this is 5. That's 1. Here's my angle theta. I'm going to use a Pythagorean theorem because that's not a Pythagorean triple. So I'm going to use a Pythagorean theorem to figure out what that little side is right there. So for the moment, I'm going to call that x. So I'm going to say 1 squared plus 5 squared equals x squared. So that's going to be 1 plus 25 equals x squared, 26 equals x squared, which means the square root of 26 equals x. Again, it should be positive or negative. We're going to assume that it's positive because we're in the first quadrant. So we don't need to worry about that. And actually, I believe the x is always going to be positive because that's the distance out. It doesn't matter. It's positive. Just leave it positive. Okay, so now we're looking for the sine of this angle theta right here. So we want the sine. Sine, I know, is opposite over hypotenuse. So the opposite side, here's my theta right here. The opposite side of theta is 5. The hypotenuse is, what was the hypotenuse? Square root of 26. So that means this is going to be opposite over hypotenuse is going to be 5 over rad 26. Don't put a box around that. Come on. What do we need to do? Let's rationalize the denominator. So I'm going to multiply both sides times square root of 26. Square root of 26, so I'm going to end up with 5 times the square root of 26 over 26. I don't think I can simplify. I can't simplify that at all. So that is going to be my final answer. Remember, no solution set because I'm not actually solving for anything. Okay, y'all, I feel pretty good about that. Here is a piece of fruit with, I don't know, top hat. Should I put it on top? Little top hat here. Little top hat. This will be your drawing for the day. A little piece of fruit with a little top hat. Hey, buddy. Let's get a little bow on there. Little, yeah. Which means he obviously has to have like a little cane. He has a little cane. And then maybe like a little monocle. And a mustache. I don't know where his face is in this whole. I guess his face is over there. I don't. Okay, well, I'm gonna have nightmares about that. Cool. Y'all, if you have any questions, like I said, send me an email, meet me in in office hours, which are listed on Canvas. You can go check that out. That's all I got. Fun times. I'll see you soon.